So welcome to Math 140 SCI. This should be lecture 19 in week 11. We are now officially more than 2/3 of the way done with the course. Try to hold back that feeling that I know you're going through of sadness that our time together is on the tail ends. It's going to be hard for all of you, I know, but I really feel that you guys will manage to pull through. I'm rooting for you all. I am. So chapter 22. Let's do this color. Chapter 22. Which we started last time. Inference about a population proportion. And I don't really recall every little detail of what we did. So if I start explaining something, you're like, yeah, you need to spend a little more time on that because we never saw it before. Let me know, and vice versa. If I try to explain something in depth and you're like, oh yeah, we got that already, tell me that as well. So you have a population. And the population has some unknown proportion P. This is unknown. So then we take a sample. And the sample gives us the sample proportion. This is calculated from sample. It determines of X, which is equal to the number of successes, divided by N, which is the sample size. Right, so P hat, I should put this really afterwards. P hat is equal to X over N. And from that, we would like to do two things. We want to compute a confidence interval. So the confidence interval, did we do this, the large sample and small sample confidence intervals? I hope we did. So confidence interval, if it's the large sample confidence interval, what does large sample mean? It means n p hats and n times 1 minus p hat are both greater than or equal to 10. If those conditions are satisfied, then we get p hats plus or minus z star square root p hats 1 minus p hat over n. That is the large sample confidence interval. And then we have the small sample confidence interval, and that's just if n is greater than or equal to 10. Doesn't require the number of successes and the number of failures each to be greater than or equal to 10, but rather just requires that the sample size be greater than or equal to 10. And you guys recall what this was? Ever written down somewhere?
Is it P, the squiggly?
P twiddle?
Twiddle, plus or minus Z star, and then square root P twiddle 1 minus P twiddle over N plus 4.
And what is P twiddle?
Isn't that we do X plus 2 over N plus 4?
Yes. X plus 2 over N plus 4. Okay. So we certainly did confidence intervals. And we are that was half of the section, so or half of the chapter. That's what we did last time. Did we talk about and yes, and we also talk about choosing the size, correct? All right, how to choose sample size for given margin of error. We definitely did. I'm pretty sure we did this. How to choose sample size for given margin of error. And we ended up with n equals what?
Is it Z score over M times P?
Don't forget the square Z star over M.
Oh, square it times P times 1 minus P.
And how do I Well, what are those P's are what? Those are not P because we don't remember, we don't know P.
X over M.
No, because remember, choosing the sample size goes before taking the sample. P hat comes from your sample. P is unknown, so I can never use that in any calculation. So I can't use P and I can't use P hats. P I can't use because we don't know it. P hat I can't use because we don't have it yet.
So it was Z score over 4M squared.
Well, there's two choices here. The book, by the way, labels this as P star, 1 minus P star. But you have two choices. Either option 2, Z star over M squared times 1/4. And option 1 was to do what? Option 1 was to use what for P star?
I don't know.
To use any previous knowledge of what P might be. So if there is a previous study that has been done that gave some value for P, use it. And the problem will be very clear. The problem will be very clear when you are allowed to use some previous knowledge. But if you have no knowledge of what P might be, you just use times 1/4. Why times 1/4? So why times 1/4 is the question. Why 1/4 when given no knowledge of P? So here's some reasons. With calculus, you can establish what I'm about to explain, but in a very straightforward way. What are some possible values that P might be? Give me a possible value that P might be. What is P star equal to? Well, it's equal to any previous knowledge of what P might be. If you have no previous knowledge of what P might be, so here, P star is equal to 1/2. So you have two options. Option 1, P star is any previous knowledge. Option 2, it's 1/2. Which is where you get 1/2 times, because then what's 1 minus P star if P star is equal to 1/2? If P star is 1/2, what is 1 minus P star? Cynthia, 1 second. If P star is 1/2, what is 1 minus P star? Also 1/2. So what is P star times 1 minus P star in that situation? What is 1/2 times 1/2? It's 1/4, which is where the 1/4 comes from. Okay, Cynthia, what was your question?
I was just kind of confused because on the notes from last time, on here, instead of the P star, you did the P with like the arrow on top. Is that wrong?
P with an arrow? You mean the hats?
Yeah, that.
No. So that was part of the derivation. As I was deriving it from the formula, I got to that point. And then I said, okay, but we have a problem here. And I waited for like an hour for someone to figure out what that problem was. And the problem was that you can't calculate P hat because we don't have the sample yet. If we're trying to figure out what the sample size should be before taking the sample. And that's what led us to replace P hat with just P, or what the book now calls P star, which is these formulas here. I didn't use P star last time, but the formula is still the same.
Okay.
Okay, so the question is why 1/4 when I have no given knowledge of P? So give me a possible value that P might be. Here, I'll give you one. If P star, if P is equal to 1/2, if P is equal to 1/2, then what is P times 1 minus P equal to? I'm actually going to use 0.5 for this. It'll be easier. If P is equal to 0.5 or 1/2, what is P times 1 minus P equal to? 0.25 or 1/4. Give me another value of what P might be. Any other value of what P might be besides 0.5. .83. If P is 0.83, what is P times 1 minus P equal to? Okay, give me another value of what P might be. 7.75. Okay, if P is equal to 0.75, what is P times 1 minus P equal to? .1875. Okay, give me another value of what P might be equal to. 1. Okay, well, if P is equal to 1, what is P times 1 minus P equal to? 0. That's an easy one. Give me another value of what P might be equal to. Okay, I can't have a P of being 4 since P is a percentage. So having P be equal to 4 will be kind of weird. 0.99. Okay, if P is 0.99, what is P times 1 minus P equal to? Give you a hint. It's 0.0099. How about if P is 0.4? What's P times 1 minus P equal to? .24. As you go through every one of the infinite possibilities for P and 1 minus P, what is the maximum? What is P times 1 minus P max? What's the biggest that P times 1 minus P could ever be? If you had to take a guess based upon what's in front of us. 0.25 or 1/4 is the maximum value that P times 1 minus P could ever be. And if you have calculus, it's very easy to prove that mathematically. You take the derivative, set it equal to 0 and solve, and you get P is equal to 0.5. Therefore, when you have no knowledge of P, wouldn't you want to make your sample size as large as possible to account for any uncertainty that you might have? Right? If you have no knowledge of P, we're going to do the worst case scenario. And the worst case scenario is to make P1 minus P as big as possible. And what is the biggest that P1 minus P could ever be? 0.25. So the reason why we make it 1/4 when we have no knowledge of P is because it's the worst case scenario. No other value of P will ever give you a number as big as 1/4. So we're making it as wide as can possibly be to cover every possible value of P. That's why it's 1/4. And if you didn't get that or don't care, that's fine too. Just know the formula. That's all that matters, which you'll have on a formula sheet anyways. So that takes us into account. That takes us to the end of confidence intervals. What I don't think we did last time is, of course, the other half, which is now hypothesis tests. I don't think we did hypothesis test for P, did we? We did do that. Wonderful. So what didn't we do last time? I mean, it's like the whole section. So what didn't we do? I don't know. Just in case, let's do it again. So let's review. Wonderful. Okay. So the null hypothesis will always be that P is equal to what? I think you said we would be doing a bunch of examples today. Oh, yeah, that's right. Okay, well, we'll do that in a second. So H naught P is equal to P naught. We have three possibilities. HA, P is less than P naught, or P is greater than P naught, or P is just straight up not equal to P naught. In the first case, P is less than, this is the critical region. In the second case, this is the critical region. In the third case, both sides are the critical region. You're right. I remember this now. My Z statistic, Z is equal to my value minus the assumed value under the assumption that the null hypothesis is correct, divided by the standard error. If the null hypothesis is correct, that is my Z, that's my test statistic. And the p-value is, of course, as always, the probability of being more extreme than the test statistic, either to the right if it's a one-sided test on the right, or to the left if it's a one-sided test to the left, or both sides if it's a two-sided test. So I do recall us doing this. So that being said, let's do some problems. And we'll just do lots of problems. So let's do it like this. I'm going to stop sharing this. Okay. And I'm going to start sharing here. Let me open up the Math 140 SCI workbook. Workbook for Math 140. Okay, so I'm going to share my screen now. Okay, so this is the workbook for Math 140. And since we've covered up to 22, I'm going to pick random questions and try not to say, oh, it's in that chapter, so therefore we must use this chapter's approach. Try to just look at the question and decide based upon what you see, what do you think the answer is going to be? So let's just do this one, pick random questions. Okay, so you have all your formulas. You have your confidence intervals, you have your hypothesis test, you have your sample size computations, and most importantly of all, you have your calculator, which is going to do the majority of the work. So in fact, I mean, that's what I'm expecting. So example 16.1 described an NHANES survey data on the BMI of 936 young women. The BMI in the sample was that. It's an SRS from a normal distribution with sigma that. Suppose we have an SRS of just 100 young men. What will be the margin of error for 95% confidence? Okay, so try to treat this like it's a test question. Pretend this was a test question. You have your notes in front of you. You have the book. And try to answer it. You go ahead. I'm going to go ahead. Okay, I got it. And just part A, because if you can do part A, you can do part B and part C. Who has an answer?
I'll just give you what I think is right. I don't even know if I did it right, but I got 2.274. Oh, yay. Okay.
Boom. What formula did you use? Interesting. Are you a mime now?
Sorry. I went on the calculator and I did stat and then calculate the Z prop interval thing. And then I added in all my stuff. But for N, I put 100. And then the way I just did the margin of error is I just subtracted the big one and the small one. But I think there's actual formula for it, but
There is an actual formula, and that's how I did it, by the way. I did use the actual formula, but the way you did it is perfectly fine as well. You got the confidence interval. You took the endpoints and you basically did half the distance, which is the margin of error.
but if I did the formula, what I would put it's standard deviation. Wait, what is the formula again?
It's Z star sigma divided by the
Oh,
square
right.
root of n.
Okay.
Because remember the formula for the confidence interval, Z star, X bar plus or minus, and then we have the margin of error, plus or minus what? Z star sigma over the square root of n.
Yeah. Okay.
Right? Z star for 95% is 1.96. And then we multiply by sigma and we divide by the square root of 100 and we're done. So let's do number 12 here. Well, first, are there any questions on that one before we go on? Are there any questions on the first one that we did? Okay, next one, number 12, go. Oh, I have some chats. 1 second, chats. I always listen for what was sigma in the last one? They gave it to me. It was 11.6. The question literally said, where is it? It's right here. Sigma equals 11.6. First thing I always do when given a problem, before I even try to solve anything, is I just write down everything that they give me. Label everything. All right, X bar, sigma, N, and the confidence. They gave me some other information here, which I didn't end up needing. I didn't end up using it, but I wrote it down anyways, because I didn't know when I was writing it down that I wouldn't need it. All right, so here we have a problem. We have some information here on top, and that tells us we're going to use it for 12, 13, and 14. So I would like you to do all three of them, 12, 13, and 14. All right, what do we got? I have an A. Can you tell me why it's A? What do you do? Not saying you're wrong, just asking what you did. Luis? Oh, he's chatting. Z interval, then subtracted. Okay, so on my calculator, you say Z interval. Did you do anything before you went to Z interval? Did you go directly to Z interval, or did you do stat test Z interval? But before stat test Z interval, what do you do first? Added the 3 weights in the, so you calculated the average on your own. Okay, so I did it a little differently. I did it by putting it into that and using my data rather than stats. But either way works. So you went to stats, then you went to a Z interval. You put your sigma as 0.001, and you did a 95% confidence interval. And when you did that, what do you get as your answer? What was your actual interval from your calculator? This is for anyone. What did the calculator give you as the interval?
Mine was 3.4129 and 3.4151, but
Yeah.
it was like different than what's given in the problem.
Yes, the reason is I would assume the reason why it's a little bit different is because 95%, if you use the calculator for 95%, it might be a rounded off version from what they use if they use a table instead, which is why it's not exact. So once you got that, how did you get your plus or minus part? What do you do? Well, yeah, no, press enter. I know pressing enter gives you the answer, but how did you get, like, in the answer is A, B, or C? It's all 3.414 plus or minus something. So the plus or minus part, how did you calculate that?
Isn't that the margin of error?
That's the margin of error. So how did you get that from what your calculator gave you in the previous step? Because just pressing enter is not enough. That's not going to give it to you.
I did the same thing. I subtracted and then I divide by 2.
Okay, and what I did very similarly is I just took the upper end minus the average.
Oh, or you could do that. Yeah.
Or you can do that. And you get 0.0011, which of the 3 is certainly closest to A more than anything else.
Wait,
Right?
I'm confused because I just, how it shows like the interval, like the confidence interval, and then you just press enter one more time and then it just gives you that exact answer.
It gives you the
No.
confidence interval as your answer.
No, it gives you 0.00113.
Wait, hold on.
You just press enter one more time and it gives it to
Hold
you.
on, I'm in right now. Hold on. Stat. And so you get to this point here. I pressed enter again. I don't get what you did.
I get like 7.5 to the power of -4 when I press enter.
Wait, hold on. So I just want to make sure. I'm here on this stage, right? You say press enter. So I press enter and it takes me there. And then I press enter again and I get nothing.
Oh, I don't know why I get it. Like it gives me point. Yeah, see, Flower also said it works.
On a TI-84 plus CE?
Yeah.
What? I want that. I want that to happen for me. I don't get that. Well, that's awesome for you guys, but I don't know why it's not happening for me. When I press enter, it goes to 1. It goes to what? It works for you guys too. So just to be clear, you get to this point right here. We're all here, right? And then you press enter here. Hold on, I got to make that louder, bigger. I mean, hold on. I'm gonna stop sharing for a second, and I'm gonna pin you so I can see it better. Okay. How do I,
Sorry, so it's on, can you see the screen? Can you see the,
I can't, no, it looks off.
sorry, it's like really dark. Well, it's basically on that screen where you're saying, and then I just press enter, and then it gives me the.
uh, that's awesome for you, but my life has just gotten a lot worse now. I feel so
Maybe
horrible.
you have to like turn it on, like in the program or something.
Yeah, but I don't know. I don't know where to go to do that. I hate my life right now.
Well, did you know that you could like, I don't know if your calculator has this, but you can, you know how you do inverse Z to find the Z star? You can do that for T, but you have to like program it in
Well, I know you can do it for T because it's built in, right?
there. Well, on yours, I don't have the cool one.
You don't have the cool one. Wow.
I would just like to say that the library told us to buy this for your class. So
Oh, okay. Well, I just found something in the catalog that says one prop. Oh, this isn't even one prop Z interval. Oh, whatever. All right. Well, my life just sucks. That's fine. It's just the way it is. Flower, I'm envious of you, but I don't know why I can't do it on mine. But if you can do it on yours, great. Okay. So, anyways, for me, what I had to do was I took the difference between the values, subtracted them. If you take the far left and the far right, that's the whole distance. So divide that by 2, you get the margin of error. Or you just do the end in the middle. Either way, you get 0.0011 or 0.00113. So that's the answer to that one. 0.0011, 3.414 plus or minus plus 0.00113. How about number 13? You want a 99% confidence interval. You don't have to do any math for this one. Because the question is, how is that going to compare to your 95% confidence interval? Will it be smaller, greater, or about the same? So don't answer it yet. I'm going to do one of my famous world-renowned quick go votes and have everyone say what they believe the answer is, or at least those people who are actually looking. So I'm going to give you 10 seconds to think about it. And then when I say go, you're going to say either A, B, or C. So 1, 2, 3, go. Okay, let's see what we have here. We got a couple B's, a couple A's, zoom back to B's, A's, A. Okay, looks like lots of A's, lots of B's, no C's, which is great because the confidence certainly dictates the interval, so it shouldn't be the same. So remember, I want you to think of confidence like a net. The more confident you are, the bigger the net you need, right? The more confident you want to catch that fish, the bigger the net. So if I want 99% confidence, that's going to be a bigger net than 95% confidence. It's going to be wider. So the answer is B. 99% is wider. If you just want to do it mathematically, then we know that Z star for 99% is like what, 2.56, I think? And Z star for 95% is 1.96. So just the Z star is bigger. Either way, you get a margin of error is larger for a higher confidence. Now let's go ahead and do number 14. All right. Okay, so when I say go, I want to see either an A, B, or a C. And again, these are very quick questions. Right, we've done a lot of examples in the calculator. So hopefully you know right where to go, what to plug in, what to do. So 1, 2, 3, go. I see lots of C's, which is fantastic because that's the correct answer. In fact, everyone who answered said C, so it's wonderful to see the answer is in fact C, so that's great. Okay, so let's go to another chapter. I don't recall what this chapter is, so hopefully it won't. Oh, hypothesis testing. Okay, good. Okay, so let's do this. The first one here. 17.5, too early. We're not doing an actual test here because we don't have enough numbers. We don't have confidence. We don't have a sample size. I just want you to state the null and alternative hypotheses. I'll give you 10 more seconds. This isn't really a multiple choice. So what I would like to see in chat is just the symbol that you would use for the null hypothesis, and then the symbol that you would comma, and then the symbol that you would use for the alternative hypothesis. Okay, so again, I want one symbol here. I'll give you an example of what I mean. This may or may not be correct. Something like that. The null hypothesis is less than, the alternative is greater than, something like that. I'm looking for two symbols, null, comma, alternative. 1, 2, 3, go. Equals less than, equals less than, equals less than, beautiful. Everyone's wonderful. Okay, so let's actually do one then. Let's do this next one. Fantastic, guys. You guys are making me proud. Okay, 7. Yeah, okay. All right. That's asking for what are your null and alternative hypotheses. I'm asking a different question. When I ask you to put it in chat, it's going to be either reject or do not reject. Actually, I don't think we have enough information. We don't have enough information. I lied. So never mind what I said. Once again, like the last one, it's null and alternative. And and what we're missing from actually doing the test. So 3 things: null symbol, alternative symbol. This wasn't really well thought out on my part, but I would like something before a comma, something after a comma, and then the third thing after the next comma is what we're missing from actually doing the hypothesis test. So sorry, I'm going on the fly here. Okay, so I'm looking for 3 things: null, either in words or symbols; alternative, either in words or symbols. And finally, what are we missing? Okay, so I'm going to give you 10 more seconds to type that out. So 3, 2, 1, go. So this is wonderful. Equal, not equal. We're missing the standard deviation or sigma. Beautiful, beautiful, beautiful. Guys, you guys are amazing. You guys are amazing. So let's actually do one. Well, okay. Yeah, okay. Let's do this one right here. Thanks. I'll pick up the close on these. Okay. Yeah. Okay. What I'm looking for here is 3 things: test statistic, p-value, conclusion. Okay, so what I'm looking for is 3 things: test statistic, p-value, conclusion. Do you guys need more time for this one?
Yes.
Okay.
Can you say again what you're looking for when we put it in the chat?
T statistic or test statistic, I mean, p-value, conclusion.
Okay.
You ready, Leanne, or you need more time?
I'm good.
Okay, so anyone else feel they need more time? Those who are trying? Okay, so we're looking for, again, statistic, p-value, conclusion. I'll give you 10 seconds to type it in. Okay, 3, 2, 1, go. Well, that's one person. Anyone else? Okay, so first of all, Celeste, I like your Z statistic, but your p-value, you didn't read the whole thing, did you? What's there at the end?
Oh, it's the E to the -5.
Okay, which it gives a very different conclusion, correct? Right?
Yeah.
Very different conclusion. But otherwise your Z statistic was correct, but the other ones weren't. Leanne, yeah,
I
Z,
put, so for my null hypothesis, since it's 20%, I put 0.2.
okay,
It should have
so
been just 20.
well, 1 second. So this is not a proportion test. This is a good old-fashioned Z test, right?
Yeah, I'm doing the Z test.
Right. So yeah, you should have put 20 because all of those numbers, 18, 19.1, 19.2, and so on, are just whole numbers, right? They're not percentages.
Yeah, because then I get what everyone else got. Okay.
So that's what I got.
Yeah, okay. Thank you.
Okay. I did a Z test, right? I actually first put my data in. So I had to go to stat and I had to input all my data. I didn't tell you to do that. I wanted you guys to realize that you had to do that. Hopefully you all did. And then on the Z test, we had sigma. Mu naught was 20 because we're working under the assumption that it's 20. And then it's a less than. We want to see if it went down. And then you go down to the bottom and you calculate, and you get a Z statistic of -4.047 and a p-value of basically 0 because it's 4 zeros followed by 259. So it's essentially 0. Okay, so everyone who got it wrong, who always didn't give me the correct number, please just quickly redo it to make sure that you get the same thing that I do. So that I know you know how to do it. And then therefore, what is the conclusion based upon our values with a p-value that small? I was tutoring someone over the weekend, and in their notes, they had the following line. It said, if the p-value is low, the null must go. But if the p-value is high, the null will fly. Now, I don't know if you ever want to say that out loud like I just did. But nevertheless, if you want to remember that, if the p is low, the null must go. So we are going to reject the null hypothesis in this scenario. Let's do, all right, let's do this one here. Number 18. I haven't looked at it yet, so let's go ahead and do it. All right. Thank you for sharing. You're welcome. What did I share? Oh, my food. It's not that good, trust me. All right. In the chat, I want you to write your test statistic, your p-value, and then your conclusion at the 5% significance level. I'll give you a couple seconds as soon as someone tells me that they're ready. Leanne, you ready? Okay. And so again, statistic, p-value, conclusion at 5%. 3, 2, 1, go.
Okay, never mind. I thought we were putting if it's significant or not.
Well, significant is the same thing as reject, right?
Oh, okay.
Okay. But the answer should be do not reject, because the p-value is not smaller than 5%. Right? So do not reject, do not reject, not reject, not reject, not reject. But Leanne, you said statistically significant, which means reject.
Yeah. I thought it's like less than or equal to 5%, then it's
Right.
statistically significant.
Well, that's right. But
It's
what
a
is
little bit over. Yeah.
a little bit over. It's a little bit over. It's enough over. Because if you look at part B says now do 556. My guess is that when we do 556 with the sample size change just by that one, we'll get a completely different conclusion, which in fact we do, right? By making X bar 556, one more than it was before, now the p-value is less than 5%, right? Which shows you that one person, 555, 556, one person different is enough to have two completely different conclusions, right? So that's what it says here. Beware attempts to treat alpha equals 0.05 as sacred, right? It's just an arbitrary number. Does that make sense? Yes, no? Right, but otherwise everyone was great on that one. So let's see what else we got here. That was great. Let's see what we can have here. I want one doesn't give us everything. Let's see, can I find one? Let's see. All right. Okay. Let's do 16. Multiple choice.
Did you say 20.16?
Oh yeah, 20.60. Mhm. All right, that should be more than enough time. So in chat, A, B, or C, 3, 2, 1, go. Right, beautiful. Hopefully you all use your everyone. Oh, wow. Well, what would be N? Well, read the question. What does it say? Luis, what's N? 25 observations. Oh, you were serious. Never mind. Okay.
So would, like, if it doesn't ask it, but would would you not reject, or would you reject it?
I'm sorry, say one time.
Would you, like, I know it doesn't ask, but would you reject this?
Oh, well, let's take a look. The p-value is 2%. So, unless they give me a different cutoff than 5%, my conclusion is to reject.
Okay.
Okay, if they said alpha is 2%, I would say not reject. It all depends on what alpha is. But without any information, what Cynthia said, I reject. Oh, while we're at it, for number 20.17, this should take all of 8 seconds just to read the question and just to say the answer. So A, B, or C for number 17. No calculations required. Well, no, tough calculation. Yeah, no, it's like all. It's okay. Okay. All right. A, B, or C. 3, 2, 1, go. All right. I got mostly A's. I got at least one B in there. But remember, degrees of freedom is N minus 1. So if it's 25 observations, the degrees of freedom will be 24, N minus 1. Okay. And of course, we already answered 20.18. So I'm not going to do that one as well. All right, let's try number 19, which is not exactly something that we did. See if you guys can figure it out. Actually, I'm not even sure what they mean by that. What critical value would you use to obtain an 80% confidence interval for the mean mu of the population?
Are they asking for the Z star?
Well, that's what I thought they were doing at first. And I calculated Z star and I didn't get one of their answers. And then Z star doesn't use the fact that there's 9 observations. So what critical value would you use to obtain an 80% confidence? What do they mean by critical value?
It's talking about T star, right? Like what would T star be at 80%?
Oh, T star. That makes more sense. Inverse T at 80%. That makes a lot more sense. Well, okay. Hold on. Yeah, that's it. You got it. Good call. Excellent job.
So, my calculator doesn't have the inverse T. I have to do like some crazy thing to program it. Is there another way for me to do it on the calculator?
So if you don't have an inverse T, no, you have to use what Stephanie did and use the back of the book.
Yeah, but like on the test, I wouldn't have that.
No, you might have a table.
Oh, okay,
Yeah, no, you might, I mean, if you have a question that would require it, you would certainly have a table.
okay.
For me, the calculator did work. So Cynthia, your question?
Yeah, I got mine like negative. Like I see the answer, but it's negative.
So you probably put in 0.1, correct?
Yeah.
Okay, so I put in 0.9 because on your calculator, it's area to the left. So if I want 80% in between, I want 90% to the left of this number on the right side,
Okay. Okay.
right?
Got it.
If you do 0.9, you get the right answer, which is what I got. So Jason, you say, how do I calculate Z star? But this is not a Z star, this is a T star problem, right? Right? So on the calculator, you should have an inverse T. Unlike the inverse Z, the inverse norm, you can't just do 80% in the center. So what I did was I did 0.9 and then I did degrees of freedom 8. And then I did to paste and it gave me the answer of 1.397. So I guess the reason why it was a little confusing to me in the beginning is because they don't specifically say that we do or do not know sigma. So if you know sigma, then I would use Z and I would use it. I don't know sigma here. They didn't give it to me. And I guess the fact that they didn't give it to me basically says, hey, dummy, you didn't know it. So, use T. And I didn't catch that. Let's do 21. Okay. So A, B, or C. 3, 2, 1, go. Yep. Good. That's what I got. Straight up on the calculator piece. Very nice.
Could you explain why we wouldn't use when it says in parentheses the actual?
Oh, that's just saying that they made up these numbers for the problem, but that the actual value is 90,000, but that's not the problem is the 70,000, but just in
Okay.
real life, it's 90. That's what they meant by that. Does that make sense?
Yeah.
Okay. All right, let's do a conceptual one because we need some of those as well. Let's do number 23. I'm just going to put something in chat to do a separation between the previous questions and the new one. All right. You need more time to think about it? Okay. 3. Well, it is around Halloween, So 3, 2, 1, go. Oh, cage fight. Look at that. We got a fight going here. A and C. Oh, wow. 3 people, 3 answers. Guess I didn't teach this one very well. Let's get some more people out there. Okay, 2 C's, an A and a B. Anyone else? Looks like we got lots of B's and C's, a couple A's, like we're all over the place here. So first I want to make sure you all read the question correctly. It says, which of these does not allow a matched pair t-test? 23. Which of these is not a matched pair t? So I just want to ask first, did anyone read it as which of them does allow a matched pair t? And accidentally answer incorrectly, because maybe that will be one of the reasons why it's all over the place. Okay. I thought we were doing 24. Did I say 20? I said 23, right? I thought I said 23. We can do 24 next. A versus B versus C. Who will wink? Who will wink? It's a good question. Who will wink? I'm going to wink. Okay. Although I think you spell with a K. But anyways. So the answer to 23 is, drum roll please, B. So let's see why it's not C. If it's the same students before and after, you can certainly match them up, right? You're not looking at 40 random students before, 40 random students after. It's the same students before and after. That's certainly a match. The first one is instructor and students in each class. So they're paired up. They're not 20 random instructors and 20 random students. They're in pairs of instructor, student, instructor, student, instructor, student. So again, they're matched up. Whereas in the second one, it's just 15 instructors and 15 students, and they got nothing to do with each other. They're not matched in any way. It's just 15 of these and 15 of those. So for matched pairs, if you can match them up, it's a matched pair t-test. But if they're not matched, even if it's the same size sample, that doesn't make a difference. If you can't match them up, then, well, it's not a matched pair. So the answer to that would be, would you say they're dependent of each other? I'm not sure if you mean dependent mathematically or just if there's a connection. There's certainly a connection between them. So yes, in that sense, the answer would be yes. They are dependent. You know, if I ask 15 random people this and 15 random people that, you know, they're not in the same class. They're not taking the same homeworks. There's no association between them. Like if I assign homework to you and you think it's too long and I don't, you know, that's going to be a very different scenario than whether you think homework is too long and some guy over there in some other college thinks his homework is too long. There's no connection between them, right? But here we're matched up. You're my students, I'm your teacher. It's a very straightforward and clear mental connection between them. Hopefully that makes sense. And let's go to 20. Did we do 21? Or did we skip? I think we did 21, right? We did 21 and we didn't skip it, did we? We did it, right? Yeah, I think we did it. So let's see, is there a simple question to answer for 21? All right.
I have a question.
Yeah.
For 20.24, we didn't do it, but would it be C? Because I just want to know for my knowledge.
Because the T procedures are robust, the most important condition for their safe use is that the sample size is at least 15, the population distribution is exactly normal, and the data can be regarded as an SRS. Well, certainly the answer is definitely not B, because robustness basically says that you can kind of relax conditions and still be okay. And if you require it to be exactly normal, that's the opposite of relaxing conditions. That's stressing, very stringent conditions. Okay, so B is certainly not right. When you get A and C, the sample size is at least 15 and the data can be regarded as an SRS. You always want an SRS. Okay, if you don't have an SRS, you can't rely upon anything that you're doing. Whereas if the sample size is not 15, that's okay. It's, you know, it's robust. It'll handle it. But if it's not an SRS, you don't even, yeah. So the answer is certainly C there. It's got to be an SRS. I'm trying to find a good one here that doesn't seem too long. All right, whatever. Only one they have here is this number 20. So look at the information for 20, and then we're going to answer a bunch of questions that use that information. So first read through 20 and write down or list whatever information you're going to need to solve the coming problems. When it says, by the way, the conservative option 2, if you recall in class, I showed you or told you a very complicated formula for degrees of freedom and said, but if you don't want to use that formula, just do this one instead. That's the conservative option 2. Okay, so if hopefully you remember what I said, I'm going to scare you again just to clear the you know, answers. A, B, or C for number 20. 3, 2, 1, go. I'm sorry, maybe I didn't hear myself. A, 3, 2, 1, go. So what's the formula for the more conservative option? You take the smaller of the 2 sample sizes and do what to it? Anyone? The smaller of the 2 sample sizes, and then you subtract 1. Yeah. So the smaller sample size is 54. So you do 54 minus 1. The answer is 53. So the answer is C. Okay, 22. Beginning minus final. Lemon and tagine. What's tagine? This is disgusting. I know what lemon is, but did I pronounce that right? Tagine? Tajin? Tajin? Oh, dried chili. can actually handle that. The diet that I'm on. Oh my God, you really had it right there. Are you anywhere near Van Nuys? I can come over and grab some. You know, send Postmates or something. No. Very good. Yeah, he insists on giving me 21, 22, 22. He's trying to make me lose weight, but I had pizza on the way home. I didn't tell him, so I shouldn't even be eating this. Like, there's no point to it. I'm just gonna stay fat forever. But yeah, okay, go. Sorry, Dad, but it's your genetics, anyways. I went to Fernanda's New York Pizza in Studio City. Air popper. Can I put butter on there? Because butter popcorn's pretty good. Popcorn by itself is horrible. Anyways, come on. You guys got me monologuing again. All right, 22. A, B, or 3? 3, 2. I didn't even do it yet. Hold on a second. Okay, I got it. 3, 2, 1, go. So everyone says C. Everyone said C. Did everyone say C? Everyone said C. So why do I think that the answer is A? Shouldn't the change be bigger for the drug than for the control group? Don't we want a bigger change?
Well, the whole problem is kind of confusing, so.
Yeah, that's why I went back to look at it, right? I mean, when I went back to look at it, the score at outset minus the score after 6 weeks, this is the numbers. And scores range from 0 to 20 with higher scores indicating more severe symptoms, right? So with the drug, we want the number to drop more, which means we expect a bigger drop for the drug than we do for the control group, correct? All right, so the way I read it is we expect the value with the drug to be larger than the value for the placebo. Right, Cynthia, does that make sense? Larger means, no, larger, no. Larger in this case means bigger change, right? We want, the drug should be a bigger change, right? If the drug works, then the symptoms should go down more. Right? Did I read that correctly? Right? We have autistic children, right? Either they get the drug or a placebo. Before treatment and after 16 weeks of on treatments, subjects are given a test measuring the frequency and severity. High scores indicate more severe symptoms. So they're going to be pretty high in the beginning. Well, yeah, but their score, no, they're talking about the change in score. That's what was recorded, right? The change in score was recorded. So if the drug is working, the change should be larger. Right? That's the way I see it. Anyways, either way, let's go ahead and just do 23 and call it a day. What is the 2-sample T statistic for this situation? All right.
What is pooled mean?
I'm sorry?
Pooled, like when you going on the calculator, it says pooled, yes or no.
So pooled is when you believe that the sigmas are the same for both.
Oh,
If
okay.
you're not given any information, we don't know sigmas, but maybe we do know that they're the same. But we don't know that here, so we're not going to pool them. Okay, so unless somewhere in the problem it says you can assume that the sigmas are the same for both, don't pool them. So I did it. I got my answer. Of course, well, I won't say anything. So 3, 2, 1, A, B, or C, go. Good. I got A's also 1.336. What's the p-value for number 24? Is it A, B, or C? For 24, I'll scare you guys again here. Ooh. So we can clear up for 24, A, B, or C.
Are you doing a countdown or?
I'll just go ahead. I already booed. So go ahead, A, B, or C. So I also get B. I got 0.09 as my p-value. And 0.09 is between 0.05 and 0.10. And that seems to be it. Okay, so how do you guys feel? Like you feel like you guys, I mean, yes, the wording on some questions might be a little difficult like the last one. How do I get 0.09? Well, the calculator gave me 0.09. Here, I'll show you what my calculator gives me. I did a 2 sample t-test. And when I pulled it, when I didn't pull it, my calculator gave me this, and my p-value is 0.09. Okay, Cynthia, does that make sense?
Yeah, I messed up on the alternative. I put not equal to, but it was greater than.
Yes. Okay, so again, no test, no class Thursday, test mini quiz only on Tuesday. So no need to show up, and we will continue on Thursday in 9 days.
Thank you.
Okay, so I hope everyone has a wonderful break, and I will see you when we get back.